Okay, Unit 9, Target 4 homework. Number 13 says solve the right triangle. Round the decimal answers to the nearest tenth. When they say solve the right triangle, they mean find all the missing parts. One standard way that we're going to do this is we're going to say that the sides across from the angles have the same letter, but we're going to use a lowercase letter. So 12 is lowercase a because it's across from angle A. 9 is lowercase b because it's across from angle B. And the hypotenuse is going to be lowercase c. So I already have a spot down there to say c equals to find that, and then I'm also going to find the two angle measures A and B because I know angle C is measured equal to 90 degrees. I want to point this out. When you have two sides of a right triangle, you can use the Pythagorean theorem to find the third side. Instead, you could find an angle and then use some trig, but you're going to have your most exact answer by using the Pythagorean theorem. You might even know some of the Pythagorean triples. So for example, I know that C is going to be equal to 15 because I know that 9, 12, 15 makes a Pythagorean triple. But I can use Pythagorean theorem. So Pythagorean theorem says leg squared plus the second leg squared is equal to the hypotenuse squared. It happens to be a squared plus b squared equals c squared in this problem, but it's not always a, b, and c. So 81 plus 144 is equal to c squared. 81 and 144 is 225, which is equal to c squared. If I take the square root of both of those numbers, square root of 225 is 15, square root of c squared is c. So c is equal to 15. So anytime you have two sides of a right triangle, whether they are legs or the hypotenuse, you can use Pythagorean theorem to find the third side. Then I'm going to draw your attention to this bottom statement. Once you have one angle measure, besides the right angle, you can subtract it from 90 to find the other. So I actually don't have one angle measure yet, so let's take that back a notch and say, I didn't tell you that yet. We'll look at that in a moment. In order to find an angle, once I have the sides, I'm going to use the inverse trig functions. So I do have this note down here at the bottom from the summary from class. It's highlighted in blue. If you have the side lengths, which I do, I have all three side lengths, and you're finding an angle, which I am, finding angle A and finding angle B, you can use the inverse sine, inverse cosine, and inverse tangent ratios. Just in case I made a mistake when I found C, I'm going to really focus on the 9 and the 12, the numbers that I'm given. And I'm also going to look at A first. So with the angle A, from that perspective, the 12 is the opposite side, and the 9 is the adjacent side. You could write those down if you wanted. The 12 is the opposite side, the 9 is the adjacent side, the C is the hypotenuse. And so my trig function that uses opposite and adjacent is tangent. So the tangent of angle A is equal to the opposite side, 12, over the adjacent side, 9. In order to find A, I have to do the inverse tangent. So I'm going to do the inverse tangent of 12 over 9. That's going to equal A. So I'll take my calculator, type second tangent of 12 over 9. And I got 53.13 degrees. A equals 53.13 degrees. Now it says round to the nearest tenth, so we'll say 53.1. And then for the last thing in the triangle, we have angle B. That's when we'll look at this bottom in green. Once you have one angle measure besides the right angle, you can subtract it from 90 to find the other angle measure. So I can do 90 minus 53.1. 90 minus 53.1 is going to be 36.9 degrees. So that would be my measure of angle B. Now you can check all this work by using any of your other trig functions. I could have done the inverse tangent for angle B. So instead of doing 36.9, I could have said tangent of B is equal to 9 over 12. So the inverse tangent of 9/12. That should also give me 36.9, so you can check that. Inverse tangent of 9 divided by 12 is 36.9 when you round it. If you wanted a way to check that you have the right C value and the right angle, you could even go a little bit further. You could say, I'm looking at angle B. I'm going to circle this in orange. I'm going to use the hypotenuse to check it, and I'm going to use either side. Let's say the opposite side from angle B's perspective. And I could check this using a completely different equation. I could say the sine of 36.9 is equal to the opposite from the orange, which would be 9, over the hypotenuse, which we said was 15. And so if you type in sine 36.9 degrees and you type in 9/15, you should get about the same number. So 9/15 was 0.6. Sine of 36.9 is 0.600. And so it's a way to check. I used two numbers that I had to find. I had to find C and I had to find angle B as a way to check that all my other math was working out.